rabbits were introduced onto an island. The number of rabbits P, t years after they were introduced, is modelled by the equation P equals 80 e to the 1/3 t. Part A, write down the number of rabbits that were introduced to the island. So the key thing here is they were introduced to the island when t was 0. T is the number of years after they were introduced. So when they were introduced, t is 0. So if I substitute 0 into my formula, 80e to the 1/3 times 0, 1/3 times 0 is 0, e to the power 0 is 1. So there are 80 rabbits that were introduced to the island. Part B, find the number of years it would take for the rabbits to first exceed 1,000. So P equals 1,000. What's the value of T when P is 1,000? So let's put 1,000 instead of P into our model. We can then make T the subject. So we're going to divide both sides by 80. We're then going to take the natural logarithm of both sides. So we'll get ln of 1,000 over 80 is equal to 1/3 t. Multiply both sides by 3. And let's just put that in as a decimal number. So if I type that into my calculator, 3 ln of 1,000 over 80, I find that there would be 7.58 years. So I'm going to say that it's in the 8 years it would take for the rabbits to first exceed 1,000. I'm saying that at 7.58 years, the population would exceed 1,000, would be exactly 1,000. P equals 1,000 when T equals 7.58. Therefore, it's going to exceed when T is above that. So I'm just going to say that T is 8 years. After 8 years, the population will be above 1,000. Moving on to part C, we need to find dp by dt, so we need to differentiate this. Now we know that when we differentiate the exponential, we get the exponential, but because of the 1/3 on the inside there, I need to multiply by 1/3. So I would have 80 lots of the e to the 1/3 t multiplied by 1/3, which is just going to simplify to be 80 over 3 e to the 1/3 t. I now want to find the population when the rate of change of the population is 50. So let's take my dp by dt. This I worked out in part C, and make it equal to 50. Let's multiply both sides by 3 and divide by 80. Take the natural logarithms of both sides. And then multiply both sides by 3 to get the number of years where the rate of change is equal to 50. So after 1.89 years to 3 significant figures, notice that's not the value of P though. So to get the value of P, I now need to take the value of T and substitute it back into the original equation to work out actually what the population is. So 80 e to the 1/3 times my answer times the 1.89. So typing that into my calculator, I find that the number of rabbits would be 150.